so to begin with, number one, you should have answered yes. And the reason would be corresponding angles are congruent and the corresponding sides are proportional. So the work that I would expect to see, I noticed that on the last test, some of you had no work, and then that was a problem because I take points off. So you want to make sure you show your work. But there's different ways to show the corresponding sides are proportional. Like, this one's really pretty easy because we're going from 3 to 9. And so you could just show that 3 to 9 is the same thing as a third. And if you multiply that by 5, in the numerator and the denominator, you get 5 to 15. So, in other words, they have the same proportional size because they're in the same ratio. Or you could show that the scale factor from the small to the large is 3 for both. That would be a good way to explain it. And then you would also say the corresponding angles are congruent. So, just to clarify, you need an answer and an explain. So here's your explain. And one way to show your work for the scale factor is to do something like this. Another way you could explain is to say the corresponding sides are proportional instead of they have the same scale factor. I'm not going to write every possible thing down. You won't be able to read it in the end. Tyson?
So do we want this to do, we need to say both of those or just one?
You need both parts. You need to discuss the angles and you need to discuss the sides. Does that make sense? Okay. So,
this is a little off topic.
Okay, let's stay on topic for right now. We have a lot to do.
About the fractions.
The fractions. That's not off topic.
Oh, okay. Well, like, would 3/9 and 5/15 be considered proportional to each other? Because
they're congruent.
Oh.
So if the fractions are congruent, because they both reduce to a third, the sides are
I
proportional.
thought because you can't go straight from 9 to 15 or from 3 to 5.
Well, you could always, so you were, I know, in a different class than a lot of the kids last year, so you might have said it differently, but basically if you could reduce them down to the same number or reduce one down and build it up, then they're equivalent fractions. Okay. So that might be just the language is a little different than what you've done, but I'm sure that you've done the work before. Okay, on the second one, what's important here is, first of all, ordering. So Q is congruent to S because it's telling you quad in this order is similar to simul. And so Q and S are the same. So angle S would be 75. But you also look over here and you need angle D, U, and A. So U is the same as angle I. And angle I was 85, so U should be 85. And angle D matches up with what? L, right? So D and L are both 120. And angle A matches up with N. So that was the value you had to stick in because I forgot to put that on the copy that you have. You needed to put that 80 in. So that's the first part. The second part is since the shapes are similar. 60 and 200 and 160. Yeah, equals 360. We okay on that?
Yeah.
Okay. So the next thing is to find SL. So I'm going to just kind of clear this off. SL is going to be the same side length as QD. I mean, corresponding to QD. You get how to read this now?
Yeah.
Okay, so when we look, we have some choices here. If the figures are similar, you could go a lot of different ways. You could compare 8 to something, so SI compares to QU, so 8 would compare to 20. Do you see that? Okay, so I like to use ratio tables a lot of the time just because it makes a nice organized way to do my work. That reduces to like 4/5, for example. I mean 4/10, right? So in other words, you could divide both by 2, the numerator and the denominator. So it's also the same as 2/5. So in other words, you can take the bigger number and multiply it by 2/5 to get the smaller number. Or you could go the reverse direction and take the smaller number, like 8, and multiply by 5/2 to get the bigger number. Because the scale factor from the smaller to the bigger is 5/2, which is the same as 2.5. So let's stop, and I just said a lot of things. Does that all make sense to you guys now?
Yes.
So you want to find the scale factor somehow. Okay, since I need more missing values on the small shape, I'm going to use well, I'm going to need to find SL, so let's see what I need to use. I need to find the small shape, so I need to take the big shape and multiply it by 2/5. Does that make sense? So you have to decide which way you want to go. So if I want SL, I have to take QD, which is 13, and I have to multiply it by 2/5. Multiplying by 2/5 would be dividing by 5 and multiplying by 2. Because it's going to get smaller, right, when I multiply that 13? Do you guys get that?
Yeah.
Okay, so that's the same. Do you remember? So we're going to go back to the multiplying of fractions. That's 26 over 5, right? Which is 5 and 1/5. So that could be one answer, or you could put 5.2. That's one way to do the problem. Does that work for you guys?
Yeah.
Any better at that? The other way, some things you can use, I'm going to put that in my picture, 5.2 here. If I look at the relationship, well, if that way works, you might just want to stick with it. Does everybody like that way? Yeah. Okay, then we should just stick with one method. So I need to do the same thing to find IM. So if I want to find IM, I need to look at UA. Does that make sense?
Yeah.
So, get a little thinner ink here. Okay, so UA is 25. So I'm going to take 25 and I'm going to multiply by 2/5. So again, that goes back to multiplying fractions. And that gives us 10. Good? Okay. Next one. It tells you this 4 is similar to square. Find the perimeter and the area of square. So I just used corresponding ratios on the last problem. I want you guys to also remember that you could use adjacent ratios. And that's a really easy thing here. To get from the short side to the long side, I just have to double, right? So to get from the long side to the short side, I would just have to divide by 2. So if you have similar figures and you see a relationship between adjacent sides, the relationship would be the same. So here, it'd be really easy to get from the long side to the short side because I could just divide by 2 and I would get 8. Does that make sense? That's why we learn 2 ways. Sometimes one way is easier than the other. Then you can get the perimeter. of the bigger one. Just the old-fashioned way, add up all the sides. So 32 plus 16, that equals 48. And it would be inches squared or squared inches. And then the area.
Wait, there's not square inches.
Oh, you're so correct. Sorry, my mistake. Inches. You are right. Good job paying attention, you guys. The area is 8 times 16. So if we look at that as 8 times 10 and 8 times 6, you just add those together, 128. And that would be squared inches. Better? Okay. Next one. Okay. Remember, you could go 2 ways on these problems. You could use the adjacent side comparison to find missing sides. That might be easier for some of you. We'll do that one. That could be a possibility. So the other way is to use the corresponding side ratios. Okay, so let's try corresponding side ratios. If I want to find the scale factor from here, the small to the large, the scale factor is going to be 21 over 6, which if I divide by 3, I get 7 halves, right? Which is the same as 3.5 times greater, right? So if you like that method, you just have to take 8 and multiply it by 3.5. So I'm using scale factor. So 8 times 3 is 24, and 8 times a half is 4, so this is 28 inches. Raise your hand if that makes sense. Did anybody do it a different way? So you guys use the proportional, okay? And I would stick with it. Most of you guys did that way. So if I want to go in the reverse direction, if I want to go from 35 to the smaller number, I have to multiply by the reciprocal of that, right? It's 2/7. The smaller side, this number that goes here, is 2/7 of the larger side. You guys more comfortable with that? And so we've spent all that time reviewing or doing fraction multiplies. Now you might see why we spend time doing that. 7 goes on to 35 5 times. So 5 times 2 is 10. So this is 10. So AC is 10. YP is 28. Oops. And these are all in inches. Yes, Tyson.
Do you want us to, is it okay if we write inches, or do you want us to do the?
Both, either. I take both.
Wait, did you scroll up or
I sure can.
I just
No problem. Okay. Okay. Perimeter of the larger pentagon if the 2 perimeters are similar. What do I mean here? Yeah, so
you know the sides?
I don't. No.
Two of the sides are similar.
Sides aren't similar. Sides are proportional. Shapes are similar.
Yeah.
Do you know, Kyle?
What?
How can I figure this out?
What I did?
Yeah, what'd you do?
I added up all of them on the first shape. Well, first I got to.
So you found the perimeter of the first shape.
Yes.
So we'll just call it the perimeter of the small shape.
And
that was, I got, what did I get?
I
87?
what? Yeah, I got 87.
Okay. So that's just by adding all these numbers up. Yes.
Then I times it. by 1.3 repeating 1 and 1/3.
Okay, how many people don't understand that? Not so much. Okay, so how many people do understand that?
Woohoo!
Okay, so let's look at it. There's two ways, and then I'll do Kyle's way first. He found the scale factor again from the small, beginning with the small and ending with the large. You always put the ending number over the beginning number, and you can compare perimeter to side length because they both have the same scale factor. And 6 goes into both of these. So you could divide each by 6. And you get 4 over 3. So you know that to get from the small figure to the large figure, he said that's the same as 1.3 repeating. The scale factor is 1.3 repeating. So he's correct. So that just means you could take the small perimeter and multiply by the scale factor of 4/3. You won't have a calculator tomorrow, so you do need to rely on your, next week, you need to rely on your fraction multiplication. You need to be able to show me your work. So 3 does go into 87. So if we practice the short division, 3 goes into 8 twice, and the remainder is 2. 3 goes into 27 9 times. So 3 goes into 87 29 times and into itself once. And now I can do 29 times 4. So 116.
Yeah, that's what I got.
So that's one way to do it. It works nicely. Okay. Yeah, there's surely a different way. What else did you do?
Well, so I found that 18 to 24 was like.
Yeah, I think that's what I did. So second method. 18 to 24, so small, just let me put some notes with it. So large. 18 to 24.
And if I got 1/3. Or,
You should have gotten 3/4 here. Right? 6 goes into both.
And then I did.
Maybe you did what he did.
Yeah, I think I did.
Okay. Just with this idea, if you liked ratio tables before, and you knew the perimeter of the small is 87, you could just figure out what to multiply 3 by to get 87. It's just another way to show your work, but you're actually doing the same thing. So it might help some of you guys that like looking at ratio tables. 4 times 29 is 116. So you still get 116 inches, or feet. Somebody had their hand up over here. Molly,
I did it.
what'd you do?
Well, I figured out that 18
Yeah, kind of like what Kyle did. Oh, you did each side. Okay. How many people did that? So think about this in a testing situation, you guys. That takes a 4-minute problem and makes it a 9-minute problem. You don't want to multiply each one of these if you can avoid it. So the point of the problem was, do you know that the relationship between the sides is the same as the perimeter? It would have worked, but they found every single side. You probably don't want to take the time to do that. But you can get to the right answer that way, so it's not wrong. It's just that you might run out of time. If you run out of time, you're probably not going to get extra time. Part of doing well on this test is understanding the efficient way to do things. That being said, the test is a little shorter. Definitely shorter. Should I keep going? Okay. So number 6, the parallelograms are similar. use the scale factor of 2.5 to find the area and the perimeter of the larger parallelogram. So what Molly did on the last one works nice here because there's not so many sides, you know. So I could do just what Molly did, and I bet a lot of you did that here. If I use that scale factor of 2.5, I'm going to just multiply each one of these numbers by 2.5 to get the larger one. So double 5 and you get 10, right? And then half of 5 is 2.5. You notice how I do a lot of that mental math? I use that, I'm sort of using distributive property. So this is 12.5 here. And double 8, you get 16. 16 plus 4 is 20. And so the method Molly uses on the last problem, I would say, is probably quicker than the, much quicker on this one. So then I could get the perimeter just by adding. So this together is 25 plus these together, which is 40. So 65 inches, right?
I just made like a mental mistake. I said 10.25 instead of 12.5.
Yeah. So correct it so you can study it.
Which do you think would be more faster, the way I did it? For like this problem, which way would be faster, the way I did it?
You know, I think it's whatever you think of first is faster. So here, you see that your perimeter of the small is 26, right? So if you think of it fast right away, that method, then you could just take your 26 and times it by 2.5. This is faster if that's what you think of first, right?
Yeah.
Because it's 26 plus 26, which is 52, plus half of 26, which is 13, and you still get 65. What's nice about that thinking, to get the area, you have to multiply by another 2.5.
That's 2.5 times 2.
Yeah, right? So to get the area,
2.5 squared.
you take your small area, 26, this is one method, times 2.5 squared. And we already know this is 65. So if I times it by 2.5 again, 65 is 65 is 130. And half of 65 is 32.5. So let me double check my work there. Anybody get that?
Wait, no, that's because
What did I do wrong?
Oh, you did the length. You gotta do the height.
Yeah, I made a careless mistake here. Hold on.
It's the you did
Oh, I did perimeter.
Yeah, that's what I was trying to say.
Sorry, my mistake. I knew something looked weird there. I need to take the area, which is 4 times 8 of the small, and then multiply by 2.5 times 2.5. That's one way. So half of, or 2 times 32 is 64, plus another half. It's 64 plus 16, 80, times another 2.5, which would be 160 plus 40. That's better. 200 inches squared. So that's one way, but it requires a lot of thinking. Another way, I bet a lot of you just found the new height. Yeah. So Kyle was asking if.
Well, actually, I did do the 10 height on the area.
So for perimeter you did one way, and for area you did a different way.
Yeah.
Yeah, this is kind of a high-end way of thinking. I think it is probably more logical to just take the 4 and multiply it by 2.5. And you get 10, right?
Yeah. 20 times 10.
10 times 200. 20 is 200. That's what I did.
That's what I need to do.
I thought you were asking about this method, Kyle.
Oh, no, I wasn't. I was asking.
Okay. Yeah. We get that?
Yeah.
So we always want to go with what's quickest and easiest for us, right? Okay. Use the ordered pair. So this is to relocate the vertices. So we're looking at this, half of each value. And then we'll start with that. So I'm just going to take my tool here and do, well, I probably should write out what I'm doing, just to make sure you guys know. So 0, 2, that's going to go to 0, 1. That's half of A, right? And 0, 2, 4, 6 is C. That's going to go to 0, 3. So right here. Okay. And then for B, B was 6, 2. You see that? That's going to go to 3, 1. Right there. And so then, you know, take a straight edge and draw your triangle in. So there's your, that's what your picture should look like. So now it asks you, we keep reading, use the ordered parallel rule to relocate the vertices of triangle ABC. So I've done that. Find the ratio of the perimeter of the original to the perimeter of the new triangle. So big to small, right? So it's 2 to 1. You could write it like this. We could write it with a colon. Both of those are ratios. You could say 2 to 1 in English, all three ways. So make sure you read. And then it says find the ratio of the area of the original triangle to the area of the new triangle. So 4 to 1. Because it's always the ratio of the perimeter squared. So 2 to 1, kind of like what we just did on that problem, times 2 to 1. And you guys, if you think about the picture, I'm going to move that for a minute. We keep going back to how, if my picture was good, pretty good, but those are kind of fat lines. You should be able to fit 4 triangles in there, right?
Yeah.
So there's 4 little ones make up one big one. Okay? But the picture plotting should be like that. Should I keep going? Okay. Below a triangle has been enlarged. Below shows. That should be. Below is shown, or a triangle that has been enlarged is shown below. Sorry about my sentence structure there. You guys got what it meant though, right?
Yeah.
So the point of,
No.
no?
No.
No,
Oh,
I thought it
okay.
meant like make up your own
A triangle that has been enlarged is shown below. How about that?
Yeah.
Sorry.
I thought I was supposed to make up my own
No,
triangle.
no.
So I kept
Okay, let's stop and look at that. You want to, are we okay there? Yeah, so all of this, oh, good point. So this should have been part B.
Yeah, that's what I thought.
There we go.
Oh.
Yeah, I'm sorry.
But then this would go to page 10.
That's okay.
Should I fix that?
Yeah, I would fix it.
Yeah.
Then I thought it's not.
Yes.
We just did like.
Let's just do the problem, right? Do you want to take a minute to think about it? A lot of you knew what I was trying to say.
No. No.
Okay.
Not.
So if you, boys and girls, yeah, I can see because I didn't type that very clearly. Okay, so class, how about I go through it and show you what the intention was, right? We have to figure out what happened. So it's an enlargement, right? So that means there has to be a multiply there. Okay, so if you look at this point D, the corresponding point is right here, and that's over 3 of 6. If you look at this point E, the corresponding point is over here and it's off the grid, so you might skip it for a minute. So if you look at point F, the corresponding point is right here, and that's over 6, 2. You don't even need that third point. Okay? So when you look what's going on from 1 to 6 to 3. Thank you. So when you go from here to here, it looks like you're doing what? Multiplying by 3. And does that work here?
Yeah.
Yes. How about from here to here? Multiply by 3, does that work here?
Yeah.
Yes. So the rule is 3x, 3y. Okay? Kayla.
I wrote x3, y3, is that kind of?
You really need to put the coefficients in front of the letters. Numbers go in front of letters. Scale factors 3. How many times greater is the image compared to the original? 3.
What if you go 3 times?
3 times.
Yeah.
With the word yes. And by what percentage has the original been increased? 2. By what percentage has it been increased? Yeah. To create the image. 200%. By what percentage has it been increased to create the image? We started with 100%, added 200% to get. By what percentage has the original been increased to create the image? No. Listen, look guys. By what percent has the original been increased to create the image?
Can you like word it a little differently next time? Does that confuse me?
Okay, they're just confusing.
Oh, I got it right.
Joni, so sorry to interrupt you. Are you teaching him proportions?
No. Scale factors. Okay. All right. So real quick, this is 115 and 115 and 115 and 115 and B and G and E and that one are all 65. Tyson.
Is it okay if we go on the side and then write ABCs?
Yes, I actually gave you answer blanks on the test.
Right?
Okay.
Yeah, okay.
Okay?
Okay, that makes it easier.
Yeah, I'll give you answer blanks. Okay. Let's finish up strong, guys. So on this problem, you're supposed to redraw 2 different triangles. So you take the big one out. I mean, you could do a sketch, right? It doesn't have to be, in other words, I'm trying to get you to visualize that. But your test is going to just kind of look like this. You should have a bigger triangle and a smaller triangle where this is 30 and that's X, right?
Yeah.
And this is 7.5 and that's 2.5. Now remember, you could do proportional scale factor, or you could do adjacent sides. So how many times do you multiply 2.5 by to get 7.5? Yeah. Yeah, or if you went the reverse direction, 7.5 divided by 2.5 is 3, right? So, in other words, these have a factor of 3 increase or decrease depending on how you go. So you could divide 30 by 3 to get 10. It's one way to do it. The other way is to do scale factor. So I need the bigger value, the bigger size. If I want to use scale factor, I could do 30 over 7.5 and figure out what the scale factor is. What's that turn out to be?
4.
Right, because 7 times 4 is 28.5. Yeah, so just division's easier there. When you do this, it ends up being 4. So that just tells you you could quadruple 2.5 and get 10. So you have two ways to do the problem. Does that make sense? So 10's okay there? All right.
I got confused almost because on your sheet on the test, didn't actually, for P to Q, didn't actually give you the.
I told you guys, you must not have heard me.
Yeah.
I told you to add the 4 in. But that's okay, because I don't think you would be confused if you had the 4. So just maybe follow along. This is 15, right? And we need to find, let's just call this X and Y. So to get from 5 to 15, I have to triple. So to get from 3 to X, I have to triple. To get from 4 to Y, I have to triple. Now in my big triangle, this is R, and I, and T. I have those letters right? So R, P, R. Well, I know that the whole thing is how much? Right here. 9. So PR must be 6. And I gave you guys the 4. And RI is 12. That make sense? Okay. Last one. Kind of the same concept. Big triangle, smaller triangle. The smaller one is 15 and 10. The bigger one is 15 here and 30. See, this is where I would use adjacent ratios, because how do I get from here to here?
Times 2.
Times 2, so why not times 2? And that makes this 20. And then RS, so I need this whole side. How do I get from here to here? Can you guys see that? Times it by what? 1.5, so times 15 by 1.5. 22.5. So you could show work for something like that, just like that. 15 times 1.5 is equal to 10 plus 7.5. Oh, 15 plus 7.5. Okay, guys, I'll post this. And then you can. Yep. Well, I have to hit stop, but.